Hi friends, welcome to another math class with Mrs. Camp. Today we're going to be working on division. We're going to be working on using the partial quotient strategy to solve division problems. Now, as a child, when I was in fourth grade, division was very challenging for me. My sister actually, she had to teach me each night because I never understood what was going on in class, even though I loved math. So division was just one of those skills that was challenging. So maybe it's challenging for you as well, and hopefully that we can make some progress in this area. So don't give up. You'll need a piece of paper and something to write with. If you don't have those things, pause this video, go grab these things so you can follow along with me. And I also wore my Albert Einstein earrings. He was a physicist because we're going to be doing lots of advanced mathematical thinking. So he'll bring us some good luck. So grab your materials and come on back. Alrighty, here we go. Here's our learning target. I can divide 2 and 3 digit numbers by a 1 digit number using the partial quotients method. You probably think that partial quotient sounds familiar because it sounds like partial products, a strategy we use in multiplication. And partial quotients is very similar. We see the part and partial, which means we're going to solve the problem by breaking it up into different parts. We're going to be subtracting out the different parts to find our quotient. So we'll be able to solve by the end of this lesson problems like 91 divided by 7 and 675 divided by 5. So here's a division problem, 127 divided by 7. Let's review some important vocabulary. The dividend is the number being divided. The number being divided. Whereas the divisor is the number the dividend is being divided by. So we've got the dividend and the divisor. Up here where the answer goes is called the quotient. So when we're talking about partial quotients, we're talking about using the parts to find the answer to a division problem. So the partial quotient method uses repeated subtraction of parts of a number. Whereas with multiplication, we used repeated addition of the parts of a number. Finding partial quotient is using subtraction. So here's how you set up a partial quotients problem. First, you're going to need to find friendly numbers, friendly multiplication numbers. We'll make a giant 7 to keep us organized, and we'll place the numbers within the giant 7 to do the math. So let's start with finding friendly numbers that'll help us. So if we're trying to solve the problem 270 divided by 5, we need to think of facts or facts using zeros that will help us. So 5 times what will help us? I always like to do 100. I always like to know what 100 times my divisor is. So 100 times 5 is 500. That could be useful. Half of that, or 50 times 5, is 250. So half of 500 is 250. So we're halving one of the numbers, so we're halving the product. And then I also like to know what 10 times 5 is. In this case, it's 50. So these are going to be important. They're going to be facts that are going to help us. So our friendly facts, our friendly numbers, 100 times 5 is 500, 50 times 5 is 250, and 10 times 5 is 50. So write these down. We don't want to lose those because they're going to help us with our partial quotients. Okay, here we go. So we're going to make the giant 7, just like this. Bring this down a bit, if I can here. There we go. We've got our facts that are going to help us off to the side. So let's place our numbers now. So we're going to place our divisor of 5. Do this with me on your paper. We're going to place our dividend of 270. Now we're going to look at those friendly facts off to the side. Which of those is going to help us? Well, the 100 times 5 isn't that helpful here. It's not helpful at all because the product is 500 and that's greater than our dividend. So we are not going to use 100 times 5. But we can use 50 times 5 because the product of that is 250 and that's less than this 270. So we're going to write our 50 over here. There we go. And you know, one thing I forgot to add, when I am doing a division problem, if it's just the raw or naked numbers, I like to tell myself a little story. So if I had 270 cookies and I was dividing them by 5 families, how many cookies would each family get? So I'm starting off by giving each of my families 50 cookies. So each of the 5 families is going to get 50 cookies. So how many cookies have I already divided? Well, 50 times 5 is 250. So we multiply 5 times 50 and we subtract it out. 270 minus 250, we still have 20 cookies left to divide between the 5 families. Now your brain might be going off. You might know a fact, 5 times what is 20? So 20 is our new number that we're dividing. 5 times what is 20? And you probably know it's 4. 5 times 4 is 20. So we're going to give each of those families 4 more cookies. We gave each of the families 50 cookies first, then 4. We have no cookies left to give out. So now we can add up the number of cookies we gave each family. 50 plus 4 is 54. Hey, guess what? We just found our quotient, 54. And we can check our work by multiplying 54 times 5. So 50 times 5 is 250, plus 4 times 5 is 20. So we are correct. 54 times 5 is 270. Nice work. Let's try some more. 5 times 830. Well, we still have our facts, our friendly facts over here that'll help us with this problem. Okay, so let's say in this case, there are 830 bees, and there's the same number of bees in each hive, and there's 5 hives. How many bees in each hive? So can we say there's 100 bees in each of the 5 hives? Well, yes, we can, because 500 is less than this 830. So let's put 100 bees in each of the hives. 100 times 5 is 500. Subtract that out to see how many bees are left to divide. 330 bees left to divide. Can we put another 100 bees in each of the hives? Nope. Nope, we'd be at 500 then, which is over 330. But we can put 50 bees in each hive because that's only 250. So that fact helps us there. When we subtract those out, we're left with 80. Can we put another 50 bees in? No, we'll have to put 10 bees in each hive now. When we subtract out our 50, we're left with 30. Okay, so if we're dividing 30 bees by 5 hives, what simple fact helps us here? Yes, 5 times 6 is 30. We have no remainder in this case. We have no bees left over. So now we just need to add up our numbers on the side. 100 plus 50 plus 10 plus 6. What is that? 166. To check our work, we can multiply 166 times our divisor of 5, and we will get 830. Okay, let's check in. How are you feeling? Can you divide 2 and 3-digit numbers by 1-digit numbers? Think about it. Are you a 3? Could you teach it to someone? A 2? I kind of get it, but I'm not quite ready to teach it to someone. Or a 1? I'm very confused. Let's do a few together. Okay. Let me move this up here. We're going to do together 92 divided by 5. Let's fill in our friendly numbers over here. So 100 times 5 is what? Yes, 500. Ooh, that one's not going to be helpful. We're only up to 92. Okay, 50 times 5. Well, half of 500 is 250. That's not going to be helpful either. And 5 times 5 is 50. Oh, we can use that because 50 is less than our dividend of 92. So, if I had 92 cookies, dividing them by 5 families, I would begin by giving each family 10. Then I've given out 50 cookies. So I will subtract out my 50 cookies. 2 minus 0 is 2. 9 minus 5 is 4. I have 42 cookies left to give out. Can I give each family 10 more cookies? No, that'd be 50 cookies, and I don't have 50 cookies. So I can go ahead and could I do 9? Well, 9 times 5 is 45. Still don't have enough cookies to give that out. How about 8? Yes, I could give out 8 cookies because 8 times 5 is 40. Now, I have 2 cookies left. So that means I have a remainder of 2 because I can't give each family another whole cookie. So I'm going to add up how many whole cookies they're going to get, which is 18. Then I need to decide what to do with my remainder. I could just put R2, remainder 2, or I could think about it as fractions if I wanted to get really fancy. I don't know if someone would want a fraction of a cookie, but it is possible. So to check this work, we do 18 times 5, which is going to be 90, and then when we add on that remainder of 2, we're at 92, so we know we're correct. Let's try another one. Go ahead and pause this video, try this one on your own, and then come on back to check with me to see how you did. Alrighty, welcome back. Let's begin by talking through our friendly facts here. Now we're dividing, our divisor is 3, so 100 times 3 is 300. Helpful or not? Nope, not helpful. Too big. How about half of that? How about 50 times 3? Nope, 150. Way too big. How about 10 times 3? 30. Yes, 30 can be helpful, but I think I want to double it because, you know what, I don't want to do all this math. I'm going to say 20 times 3. I'm doubling one of my factors so I can double the product. 60. Yes, now you're speaking my language. 60 will be less math. So let's tell ourselves a little story. Let's say there were 81 leaves on 3 trees. It just so happened that there were the same number of leaves on each tree. Yeah, right, but hey, well, it's math. We can do what we want. So let's say that we're going to put 20 leaves on each tree. Okay, so now we've given out 20 times 3 is 60. We've given out 60 leaves, and we have 21 leaves left to give out. Hey, your mind might be going off about a simple fact here. 3 times what is 21? Ooh. Yeah, so 3 times 7, we'll put right there. 7, not a very good 7, is going to be 21. So we're going to subtract out our 21. We're left with 0. So in this case, we don't have a remainder. I'm not going to lie, I love when division problems don't have a remainder. It seems very satisfying. So 27 times 3, I know I'm right because 27 times 3 is 81. Nice work on that, friends. Let's try one more together. Oh, we might try one more. Yes, we're going to try one more together. 107 divided by 4. Pause that video. Give it a whirl. Think about what we know about hundreds and quarters. Maybe that'll help you do it a little quicker. And then come on back and check in with me. Alrighty, we're back, friends. How'd you do? Let's talk through this together. 100 times 4, is it helpful? No, it's 400, not helpful. How about half of that, 50 times 4? Not helpful, it's 200. How about 10 times 4? Sure, that's helpful. That's 40. However, there's something else a little more helpful. And those of you who are thinking about quarters and hundreds, we know that 25 times 4 is 100. Did any of you think of that? That if we were dividing, we could give each of the groups 25? So like, let's say that I had 107 pieces of candy, and I was dividing them by 4 friends. I don't like to share my candy, but I guess I will. And I'm going to give each of my friends 25 first. The reason I'm going to give them 25 because I know 4 or 25s is 100. Like 4 quarters is 100 cents. And then I'm left with 7 pieces of candy to give out. And I can give them each one more. 1 times 4 is 4. I'm left with 3 pieces of candy, friends. And I'll probably keep that for myself, but in math I got to call it a remainder. I guess I could split up the candy, but it might get messy. So my quotient is 26, remainder 3. Now, one of my brilliant students I was talking to the other day, they like to predict when I multiply 26, I didn't get my 3 in there, times 4, what's it going to be? And they would know it's going to be 104 before they even got started, if they did the problem right with a remainder of 3. So 26 times 4 is 104. Add 3 more on, we're looking at 107. Very good. How did you do on that one? Let me turn off my writing here. Go to my next slide. Oh, we got one more. Pause this video. Come on back after you've given it a shot. Alrighty, welcome back. What is helpful in this case? What friendly facts? Well, in this case, 100 times 2 is helpful because that's what? You got it, 200, friends. How about 50 times 2? That's right, that's 100. Okay, and how about 10 times 2? That is 20. Okay, so if I have 458 puppies, I'm wild, I love puppies, 458 puppies, and I'm sharing them with myself and my husband, yeah, so they can all live in my house. How many puppies will we each get? Well, could I give each of us 100 puppies to start off with? Yes, but I could also give each of us, Jerry and I, 200 puppies. Because 200 times 2 is 400, and that's still less than my dividend. So we'll minus out my 400 here. And I'm left with what? 58 puppies to give out. Now, you might be thinking, Mrs. Camp, 4 25s was 100. 2 25s is 50. So let's give each of us 25 more puppies because 25 times 2 is 50. Now, if you didn't do that one, if instead you decided to take out like 10 at a time, that's just fine. Cool thing with partial quotients, you can do it any way you want. We're left with 8 puppies to give out. 2 times what is 8? You've got it, 4. We have no remainder of puppies, thank goodness. Puppy remainders would be very sad. We need to add up all the puppies we each get. Oh my goodness. We're each going to get 229 puppies. That is our quotient. It is a very good day. Why can't this be real? Alrighty, nice work on that, friends. Let's check in one more time with that learning target to see how we're doing on making progress towards our math goals. We're not going to skip that one. I can divide 2 and 3-digit numbers by 1-digit numbers using the partial quotient method. How are you doing with partial quotients? How did it go for you? Maybe you're not a partial quotients kind of person. Maybe you're more traditional division. But either way, I'm very proud of you for checking in. Do the practice problems and let me know if you need any help.